Hi everyone. We are going to start chapter 7 now, which is on radicals. So this is kind of a major departure from what we've been doing over the last chapter or two. And so we're going to talk about square roots and cube roots and fractional powers and all of that sort of stuff over the next two videos. So in general, we can change a radical from the kind of the root look. The root look would be this first one up here on the top. This would be written as a root, whether it's a square root or a cube root or a fourth root or whatever. And we can change that to be a rational power. So this would be your rational power. And what you want to notice is the power, the p on the inside of the root, becomes the top number on the fraction, and the r on the outside of the root, whether it's a cube root or a square root or whatever, they want you to put that as the bottom number under the fraction. If the r is not listed, it is understood to be a 2. And if the p is not listed, it's understood to be a 1. So for instance, if you just had the square root of x, there's no 2 in front, there's no 1 on the x, but that is the same thing as x to the 1/2. They are the same thing. This pops up a lot in various courses as you go on beyond this course. So when it says to simplify, what they usually mean is to switch from one to the other, either change it from the root formation to the rational power, or the other way around. And so here we're going to go from a radical to the roots to the rational powers. And so what we can do is just take the 20 that's on top, comes from the number underneath the radical, and the 4 on the bottom comes from the number out front. The number out front has a fancy name. It's called the index. So if you've heard index before, this is a fourth root, and the 4 is the index. But you can simplify this because 20 divided by 4 is just 5. So that's just x to the 5th. Or on B, same idea. This would become x to the 36 over 6. The 36 underneath divided by the 6 out front. 36 divided by 6 is 6, and so this is just x to the 6th. Usually if we're going the other way from a rational power to a root, that's usually because the rational power doesn't simplify anymore. So like on part C, we have x to the 3 over 5. 3 over 5 does not simplify, and so what we could do, we could change it back to a radical format. The 5 on the bottom would go as the index, the number out in front of the radical, and this would be x cubed. And that's all you could do. On these type problems across the answer palettes on the bottom of your homework site, you're looking for a button that has a blank with the radical and a blank. So the little blank is where the 5 would go. The big blank was where you'd actually put the x and the cubed. So I kind of mentioned this one on the previous page, but x to the 1/2, that is technically just the square root of x because it's really the second root of x to the first power. But usually this 2 in front and this 1 on top is an understood. We don't usually write those, so we just write it as the square root of x. So square root of x and x to the 1/2 is the same thing. Now we can do this with numbers as well, and sometimes the numbers simplify and sometimes they don't. So for instance, the 216 raised to the 1/3 power, you actually could type this into the calculator just to see if you end up with a actual whole number coming out very, very nicely. If you don't want to, that's okay. You can do it out by hand fairly easily. This is saying the same thing as the cube root of 216 to the first power. And again, you don't usually write the first power, so it's only really asking what's the cube root of 216. That's saying what number 3 times gives you 216? Now you might have to try that in the calculator a few times. Going just like 3 times 3 times 3, that's 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. But 6 times 6 times 6 is 216. This is the same thing as 6 times 6 times 6. And so I have 3 6's underneath. So the cube root of this becomes the cube root of 6 cubed. And if you were to change it back to a rational power, it would be 6 to the 3 over 3. Or 6 to the first, which is just 6. Now there's a lot of detail there that you may not need to know. If you look at it and say, what number 3 times gives you 216? The answer is 6. That works. But this is the longer, drawn out, why is it 6 version. So you may not need that much, and that's okay. And that kind of leads into the idea of what a factor tree is. So a factor tree is where you factor a number under the radical until you have it as far down into its prime factorization, so you can't factor it anymore. We rewrite the numbers under the radical so that the exponents match the roots, which is what I kind of did on that last problem, and move the base out front, and then anything left over stays inside of the radical. And we can do this with numbers. We could also do it with letters, and we'll do a little mixture of both on the next few problems. So to begin with, 90. Square root of 90. The square root of 90 is not a nice number. If you type in the square root of 90 in the calculator, you'll get some long decimal number a little bit less than 10. It's about 9.48683, la 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 la. And so, because of that, it will simplify, just not very well. And we'll have to do what we were talking about with a factor tree. So, I'm going to come over here onto the side. I'm going to say this 90, I can split it up in 2 different ways. Or 2 different numbers. And the numbers don't matter what they are. You can choose whatever numbers you want to. But I can make it 9 times 10, for instance. As long as those 2 numbers multiply to give you 90. The 10 would go to 2 times 5. The 9 would go to 3 times 3. And that's as far down as you can possibly go with this problem. And so I would rewrite this as 3 squared, because there are 2 3's, times 2 times 5. Now, the 3 squared, the 9, I can do the square root of 9, that's just 3, right? Or you could take it kind of like what I did on that last one and divide it up into each one. But the square root of 3, square root of 3 squared, sorry, is just 3. Its base matches the root, so we pull the base out in front. But nothing else matches. There's no powers on the rest of them. So the 2 times 5 just stays 10. And so that would be my answer. Let's try another one. The 75. 75, I could write it as 25 times 3, for instance. The 3 you can't simplify anymore, but the 25 is 5 times 5. So this is actually 5 squared times 3. That power on the 5 matches the root. You're taking a square root. So the square root and the square root match, so you pull the base out in front. And the 3 gets left over. And that's your answer. For those of you going into college algebra after this, this is about where college algebra picks up, so you'll see the same sort of thing at the beginning of college algebra as well. On letter C, you have the cube root of 16, so you need your powers to have 3's on them before you can bring them out front. So 16, I could make that be 4 times 4, or you could do 8 times 2, or some combination. This is 2 times 2, and 2 times 2. So we actually have 2 to the 4th power. But our power doesn't match our number on the outside of the root. But I could kind of split them up as, instead of taking all 4 of them at once, why not just take 3 of them and leave the other 2 where it is? And say that this is the cube root of 2 cubed times 2. I can do that. That way the 2 cubed, that power matches the power on the root on the outside. So I could pull that base out front and leave the other 2 underneath. And so the cube root of 16 is 2 times the cube root of 2. And that would be the same thing. Hopefully that makes sense. These things over here on the right-hand side are your factor trees. Okay, let's do it with some letters. Actually, the letters are easier to do than the numbers, in my opinion. For instance, this first one, I have the square root of 16, x to the 7th, y to the 4th. So the 16, I can do the square root of 16. That's just 4. And so I could rewrite this as 4 squared, x to the 7th, y to the 4th. And so since the power on the 4 matches the radical, then you can pull the number out in front. And so I would pull the 4 out in front. The x to the 7th, this is just like we were doing a while ago when we divided our powers. The power underneath divided by the number out front, the understood 2 here. I would have x to the 7 over 2. Now, 2 doesn't go into 7, so this is very much like 4th grade division. You have to divide. How many times does 2 go into 7? It goes in 3 times with 1 left over. The 3 that it goes into comes out in front. The 1 that's left over stays underneath the radical. On the y to the 4th, though, y to the 4th divided by the 2 that's in front, that divides evenly. That's just y squared. So that y squared can come out front with nothing left over. And the nothing left over says this is my answer the way it is right there. Okay, on part E, we have the square root of 32. The 32 does not simplify quite as well as your 16 did on the previous one. So 32 would be, say, 8 times 4, which would be 4 times 2. The 4 would be 2 times 2, and this 4 would also be 2 times 2. So I could rewrite this. This is actually just a whole bunch of 2's. There are 5 2's. So I have 2 to the 5th, a to the 6th, b to the 5th. And just like the other one that we did a while ago, the power does not match the number on the outside. This is a square root. But I could rewrite this as 2 squared times 2 squared times 2. That way the power on the 2 matches the power for the root. So you can pull those numbers out in front. So the 2 squared, I could pull the base out in front. The 2 squared, I could pull the base out in front. The other 2, I would stay underneath the radical. And then you divide your powers on the letters. A to the 6th, this a to the 6th, would get divided by the 2 in front. So I have 6 over 2, which is a cubed. That divided evenly, so I would move it out front. Or b to the 5th. B to the 5th does not divide evenly, so I'll have 5 over 2. So you have to say, how many times does 2 go into 5? Well, 2 goes into 5 2 times. 2 times 2 is 4 with a remainder of 1. So the 1 remainder stays underneath the radical. The 2 that it divided into evenly comes out in front. And then I can just multiply the two 2's in front together and make this 4a cubed b squared times the square root of 2b. And that would be your answer. On part F, we're doing cube roots here, so you need the numbers to match with cubes in the front. So my 24, I'm going to say that's 8 times 3. The 3 doesn't simplify anymore, but this is 4 times 2, or 2 times 2 on the 8. So this is the cube root of, there's 3 2's and a 3 on the x to the 12th, y to the 11th. So the 2 cubed does match with the power on the 3 on the outside. So I can say, pull that out front and leave the cube root of 3 underneath the radical. As far as the variables, the x to the 12th divided by 3, that divides evenly. That's just x to the 4th. So I can pull that out in front. The y to the 11 over 3 does not divide evenly. So if you divided 11 by 3, that will go in 3 times. 3 times 3 is 9. Gives you a remainder of 2. So the 3 that went in evenly comes out in front. The 2 stays left over underneath the radical. And we're left with 2x to the 4th y cubed times the cube root of 3y squared. So hopefully that makes sense. The numbers you have to match with the powers on the outside like we did earlier. The variables, you just divide them and see if you have a remainder left over. Okay, if you have a negative involved, if your root is an odd number, so you're doing a cube root or a fifth root, and the base is negative, the answer just stays negative. If the root is an even number, like a square root or a fourth root, and you have a negative on the inside, you just don't have an answer. You can't do the square root of a negative number. But if the negative is on the outside, it doesn't matter if it's an even root or an odd root. If the negative is on the outside, the negative just comes along for the ride. It's not doing anything. So you just multiply it by whatever you get after you simplify it. So this first one is like that third situation. There's a negative on the outside. I have to do the square root of 256. Now, if you did the square root of 256, that is a perfect square. 256 is 16 times 16. Now, 16s can keep being simplified if you want them to be, but if you ever run into the situation where you have two numbers be the same thing, you can just stop. This is negative square root of 16 squared. And so the square root of 16 squared, they cancel each other, so this is just negative 16. And that's an okay answer. If we have something like the cube root of negative 64, the negative, since it's an odd root, this value right here, this is an odd number, and so that 3 being odd says the negative just comes out in front, and you just simplify 64. 64 is 8 times 8, which is 4 times 2 and 4 times 2, or 2 times 2 and 2 times 2. I'm doing a cube root, so I need groups of 3 together. So I'm going to have the negative cube root of, if I take one group of 3, here's a group of 3, and there's another group of 3, it's 2 cubed times 2 cubed. So since the power matches the index, or the number on the outside, they let you pull the base out in front. So we'll just have negative 2 times 2, which is negative 4. Both the first one and the second one, if you just type them in the calculator, you would just get negative 16 and negative 4. On the third one, the fourth root of negative 729, that is an even number. That 4 is an even number. And this negative right here is a bad thing. You can't do a negative number underneath an even root. This has no solution, or no real solution anyway. There's no work to even be done. Okay, what if you had radicals on fractions? Well, those aren't too bad either. You just take the radical on each piece. So if I do the square root of 25 divided by 64, this is really the square root of 25 divided by the square root of 64. The square root of 25, that is 5 squared. 64 is 8 squared. So the radical cancels the squared just to give you 5/8. Now sometimes the numbers don't come out quite that nice. Like on part B, I would have the square root of 18 over the square root of 49. The 18 is not a perfect square. It is 9 times 2. Square root of 49 is 7 squared though. But 9 is 3 squared. So the squareds match the powers of the radical, so I can move it out front. So this becomes 3 times the square root of 2 all over 7. So instead of doing my factor tree kind of off to the side, I did it along the way on the top. Okay, this has rational exponents, but remember, that's the same sort of thing as a radical if you want to change it back. A 1/2 power, this is 9 over 16 to the 1/2 power. A 1/2 power is the same thing as a square root. So this is actually saying the square root of 9 over 16. And I could do the square root of 9 divided by the square root of 16. 9 is 3 squared. 16 is 4 squared. So the radical and the squares cancel each other to give you 3 over 4. Part D, kind of the same idea. We have a 4/3 power. The 3 on the bottom tells you it's a cube root. Now, we talked about negative exponents way back several chapters ago. If you have a negative exponent, then you can take your fraction and flip it over to make it a positive exponent. So that's actually what I would do first. I would rewrite this as 64 divided by 27 to the positive 4/3 power. And then the 3 on the bottom tells you this is the 64 over the 27, has a cube root on it. The whole thing is raised to the 4th power. Now, if you have the option, the radical is the easier part to start with. So I'm actually going to do this as the cube root of 64 raised to the 4th power over the cube root of 27 raised to the 4th power. It's easier to do the radical than it is the power. And so 64 is 4 cubed. 4 times 4 times 4. 27 is 3 cubed. And both of those have a 4th power on them. That way the power on the 4 cubed matches the 3 in the front. So they just kind of cancel each other off to give you 4 to the 4th on top. On the bottom, same thing. I'll end up with 3 to the 4th. 3 to the 4th is 81 for 3 times 3 times 3 times 3. Sorry, I went blank for a moment. And 4 to the 4th is 256. And so this would be 256 over 81. You could probably also type this one in the calculator if you wanted to. You might have to use a fraction button to change it back to a fraction, but you could probably get by with that. Okay, if you want to multiply radicals together, as long as they have the same uh, root, you can multiply the stuff underneath. So like for instance, the square root of 7 times the square root of 10, you just multiply the 7 and the 10 and say this is square root of 70. Now you do want to check to make sure it simplifies or not. In this case, 70, if you took the 70 and split it up as 7 times 10 or 2 times 5 times 10, there's no way to get something squared off of that. And so it doesn't simplify. We just leave it like this. On part B, they're both cube roots, so we do the cube root of 8y. Or if you wanted to, you could notice that the cube root of 8 could be simplified. 8 is 4 times 2, or 2 times 2 times 2. So this is actually the cube root of 2 cubed times y. And since the power on the 2 matches the power on the radical, you pull the 2 out front. And you could put it as 2 times the cube root of y. Same thing on this one. I don't know why I wrote that on the top again, but when you do multiply radicals, you keep the root and multiply the numbers underneath. So the cube root of 3 times the cube root of 5 would just be the cube root of 15. That one again does not simplify because the only thing to give you 15 is 5 times 3, and that doesn't simplify anymore. So the last one down here at the bottom has a little bit of everything in it. It has a fraction, you got to do some simplifying, it's got a variable to a power. So we're going to do a little bit of everything on this problem. So first of all, I would do the cube root on each one. Do the cube root of 80. And if you want to go ahead and do cube root of x to the 10th separately, you could, or you could put it underneath. It doesn't really matter. I'll do it separately. And then the cube root of 27. 80 is not a perfect cube, but 80 is 8 times 10. X to the 10th, I would change to 10 over 3. And the cube root of 27 is the same thing as 3 cubed. 8 is 2 cubed, like we just saw earlier. So, because I'm running out of room, I'm going to erase the 8 there and put a 2 cubed there. That way I can move the 2 out in front. So this will become 2 on top. And I'll have a cube root of 10 that doesn't simplify anymore. The x to the 10 over 3, if I take 10 and divide it by 3, it goes in there 3 times with a remainder of 1. So the 3 that it goes into it comes out in front. The 1 that's the remainder stays underneath the radical. And on the bottom, I'll have 3 cubed matches the 3 on the front, so you just drop that off. And I end up with that answer right there.